This question caused quite a lot of upset, and in many ways, it's the kind of question you're more likely to find in a sort of maths challenge type paper than a GCSE paper. That said, um, it's not that hard to solve once you figure out a way of thinking about it differently. Um, ABC is an equilateral triangle, so obviously these angles here are 60 degrees, and that's going to be quite useful. So let's put that in. Um, and there's arcs of 4 centimeters drawn to cut the sides of the triangle, so you get the shapeless form. Now, the key thing here is that these are arcs, which means that they are each curved section here is a sector of a circle. And because that angle is 60 degrees, this is a sixth of a circle, that's a sixth of a circle, and that's a sixth of a circle. So when it comes to working out the area and the perimeter, you need to think of those parts of the shape in those terms. This length here is going to be 1/6 of a circle radius 4. This is also going to be 1/6 of a circle, of the circumference, sorry, of a circle radius 4. And this is going to be 1/6 of the circumference of a circle radius 4. If you put together 3/6 of a circumference of a circle radius 4, you have half the circumference of a circle radius 4. So effectively, that blue, those 3 blue lines, which make up the perimeter of the shaded shape, are half of the circumference. Which is a half of 2 pi r. And the radius is 4, and the half and the 2 will cancel. So it effectively becomes pi times r, which is pi times 4. And I ask for that to 1 decimal place, which is going to be 12.6. Now, I shouldn't really have written that as 4 pi. I should 12 pi 4. 4 pi 12.6. Now, for the area of the shaded shape, it's going to be the area of the triangle minus the area of the 3 sort of sectors of the circle. So the area of a triangle is given by the sort of new GCSE formula, not the old one you knew, a half AB sine C. Where A and B are 2 lines in the triangle and C is the angle between them. So if we take that as our A and that as our B, and that is the angle between them, we've got A is 8, B is 8, and C is 60. So that gives us a half times 8 times 8 times sine 60. And sine 60 is root 3 over 2, so that gives us 16 root 3, which comes to 25.1. Something. Is that correct? No, my mistake, I'm reading the wrong bit. It's 27.7. Or thereabouts. And then that's the area of the triangle. And then we need to subtract from that the area of the 3 sectors of the circle. And those 3 sectors of the circle, because they're each 1/6 of a circle, they add together to make half a circle. So I'm going to write that as a semicircle, even though it doesn't look like it. It's the 3 sectors of the circle stuck together. And that's going to be a half of the area of the circle, which is a half of pi r squared. And the radius of the circle is 4. So it's going to be a half times pi times 4 squared, which gives us 25.1, dot, dot, dot. And the difference between them comes out as 2.6. That's the triangle area minus the area of these bits. That goes the area of the middle. That comes out as 2.6 centimeters squared. For the units for the first one.